Good afternoon and welcome to yet another edition of Embedded Executives. My name is Rich Nass. I am with Open Systems Media and Embedded Computing Design. My guest this week is Carl Schlachte. He is the president, the CEO, and the chairman of Ventiva. How you doing, Carl?
I'm doing well. Thanks for asking.
So, real quick, what do you guys do?
Uh, what Ventiva does is we make thermal management products. We make technologies that are designed and implemented to be able to cool small, thin, light electronics.
Okay, I know we talked about what we're going to talk about, but now I'm going in a different direction. Um, are we talking about like fans, heat sinks,
Mhm.
modeling software, all of the above, none of the above?
All of the above. The fundamental piece of our technology is a device that moves air in a very unique fashion, and I can talk about that in a little bit if you want me to. But in terms of air movement, that has to be connected to something that's going to help you with the heat. So things like fin stacks, heat pipes, all the rest of it. So we will design that entire thermal subsystem to help somebody conquer a heat problem.
So, are you typically talking about something that's like a wearable on a battery or something that's in a rack or both?
It could span all of those applications. The stuff that we're getting designed into right now that you'll be seeing in the marketplace are laptops, particularly thin. I'll call them thin, high performance laptops. Those will be the kind of things you'll see late 26, early 27.
Okay, that's a good place to start then, because that
Hmm.
to me presents a huge challenge. They're
Yep.
getting smaller, they're getting thinner, and like the name implies, they're often on your lap.
Yep.
And I know I've been burned by a laptop before.
Yep.
Is it still the same old problem? The batteries get super hot, the processors get super hot. I know we don't have spinning disks in them anymore, but are those
Mhm.
generally your problem areas?
Yeah, in general, yes. And I think you hit the high points. It's a very constrained environment, thin. The shape doesn't really get to change a whole heck of a lot. Your hands generally fit a certain type of keyboard. You've got a screen that folds up from it. So there's not a lot of places to put things that will help cool the laptop. And then on top of that, you've got all the other things that nobody likes about laptops. The fans start to spin up. It gets very loud.
Mm-hmm.
That's the laptop trying to move extra air. Interestingly, and the reason we get called on a lot is that in order to make a fan quieter or more user friendly, typically the fans get bigger. So they make a bigger fan and they turn it slower. And as you can imagine, real estate in a laptop is at a premium. And the moment you make some of the components very, very big, you're taking away from your ability to do something else. So when we show up for to help a laptop designer, we're actually taking part of that problem away. Not only are we moving the air, we're moving it silently, and we're doing it in a small modular fashion that lets them put some innovation back into the machine itself.
So, in your words, when you show up to help, how
Mhm.
much leeway do they give you? Because at some point they may say, yeah, we've already laid out the board and this is what we got. Or,
Okay.
I mean, that sounds like a far bigger problem than, hey, we're about to lay out the board, show us what we should do.
So you're touching on, I think, the central problem in the industry when it comes to things like thermal management. And the central problem is thermal management tends to be the last thing that's done. And you said it, I think you said, Rich, I think you said it exactly perfectly, which is to say that the board is already laid out. You got the battery, you got the screen, you know exactly what you're putting where. Please now just throw enough air at this thing in order to keep it cool. And this is not just a Ventiva thing. This is true for any air moving device that goes in the system. And the result of that is you're left with only a very few levers to pull to try to design a system that consumers want. And again, the challenge for a lot of these laptop folks is that when you're confronted with that problem and you're solving the worst part of the problem at the very end, you aren't allowed a lot of innovation. Just by the nature of the beast, and I'm not talking about anything to do with anything other than at the very end, if I have to remove 18 watts of heat or 30 watts of heat, there are not many things that I can do in order to do that.
Is the answer ever use a different MCU, for example, that one that runs much lower power, or are you guys okay? This is the bomb, and this is what I got to work with.
Typically, You can, yes, you can go in that direction. You can, and a lot of systems take advantage of that already, which is just, the laptop you're using right now probably has the ability to throttle down the processor so that it can run cooler and not turn on the fans. But if you throw a heavy compute intensive type application at it, it'll probably get very hot, and then you'll hear the fans spin up. Um, the where that what's happening today, which has made the problem fundamentally more interesting for companies like Ventiva, is that you've added AI into the equation. And as soon as you add an AI client onto your machine, you've added an additional heat load that wasn't there before. So imagine taking your tried and true laptop design with two giant fans in it and an Intel Meteor Lake processor or something like that. And now you're adding in an extra AI problem on top of it. You've just increased the heat load by a whole heck of a lot. And again, if you're trying to solve that problem at the very end of your design cycle, you got some pretty big issues.
Is there always a fan in these systems?
There are systems without fans, but they are compute limited. So, for example, things like a MacBook Air typically do not, and I think this is true for all MacBook Airs, they do not have a fan in them. And also, then you are keeping the processor, call it an M3 or an M4 from Apple, running at a relatively lower state in order to keep the entire thing cool.
So they throttle back the CPU just because of the heat.
Everybody does. Everybody throttles the CPU because of the heat problem in a laptop. That is a given. Otherwise, you would run the thing flat out. Well, you would do two things. You're running the CPU at a lower rate to keep it cooler, also to not drain the battery as quick. So I don't want to minimize the whole battery situation as well. But that in and of itself is a heat problem, right? You've got batteries generate heat, and you've got to cool that as well. So there's this constant load balancing going on if you're a laptop designer. That's one of the reasons it's a particularly useful market for us is on the Ventiva side. If we can solve the problem in a laptop, we can solve it pretty much anywhere. And then I also want to say the reason that not just for us but for everybody, the laptop is a particularly interesting space because it is the front end to this giant cloud compute AI client. It's the client. It's what you and I understand as AI happens in the laptop, not in some data center in Des Moines, Iowa, or something like that, right? Where our AI as a utility or as a service for us gets realized inside of a laptop, and the laptop is thermally constrained. That's a big issue.
Are you also constrained by, I'm probably painting people into a bad box here, but a potentially a temperature sensing device that might cost a nickel that's actually responsible for the life and death of this system?
It happens all the time. Your solid state drive is generating heat. You've got a battery monitor that's generating heat. You've got not only the CPU generating heat, but you've also got memory modules and a slew of other components scattered throughout the system that generate heat, and you end up with hotspots. The answer to that has traditionally been I will put big enough fans in the system that have enough pressure and flow to pull enough air through the system so that even if the hotspot is in some weird corner of my motherboard, I can pull air over it and cool it. That's actually a pretty inefficient way of doing this. It'd be much better if you could put localized cooling or localized air movement where you have the hotspot, and then use that as a way of developing your system on the basis of I don't care where the hotspots are. I'm going to take care of those being cool. I'm going to design a system that is heat placement agnostic, as it were. If you could do that, you end up with a much more compelling system, a much better client for customers like you and I.
Do the heat characteristics of components change over time? Does an old battery generate more heat than a new battery? And the same thing with the semiconductors?
Sometimes, yes. Generally, staying focused on laptops, you're trying to design for a system for a 5-year lifetime. So you do see components degrade over time. It doesn't always end up as a heat problem over time, as much as you might have to drive some component harder in order to get its performance back to where it was. But that would be a typical use case in a system.
Okay. Do you ever take a device apart and say to the whoever designed it, hey, if you've done this, this, and this, we could have saved you,
That is exactly what we do. As a matter of fact, tomorrow afternoon we're on a call with a laptop company where we're going to show them our like we dissected it, and if it were us, we'd do it this way. And it can get really unique. I mean, we crack a lot of jokes about laptops around here because we work on so many of them. But the truth of the matter is, I could probably show you a laptop from 10 years ago, and you would have trouble telling me if it was a 10-year-old laptop just looking at it. There's almost zero innovation in the space, largely driven by the fact that the thermal management system can't change.
right. Would you record that meeting tomorrow and send me the recording, please?
Yeah, no.
Very good.
That's a fair question.
This is really cool stuff, and I'm really glad we spoke. There's a lot to be learned here, and hopefully people will take advantage of the tools that are at their disposal.
Thanks, Rich. Appreciate your time.
That was Carl Schlachte. He is the president, CEO, and chairman of Ventiva, and I am Rich Nass with Open Systems Media.